thought I'd just put up some streamers so that you can see the different spokes. You can go to an anatomy book and look at these things, but it's useful to see it in full-blown abstract color. Yeah. So one of the muscles that is very prominent that connects the legs to the spine is a very long muscle, which is actually quite, sorry for those of you who are vegetarians, but it's actually quite delicious. It's called the psoas, the filet mignon. Yeah? And it goes along here, goes over this rim, comes back under here, and joins there, like that. So you can see it's a very extensive muscle, spanning a lot of joints, right? 1, 2, 3, 4, 5, 6 joints. It spans a lot of joints, moves a lot of stuff. Yeah? And then you have another muscle that it's kind of its partner, but doesn't span so many joints. It spans far fewer joints, and it lives kind of in here, goes around this corner, and joins here again. And that muscle's called the iliacus because it comes from the ilium bone. Very inventive, these people. Yeah, ilium bone to here. So already here you have a very strong connection. These are some of the strongest muscles to bend up your leg. But given that they can bend up your leg, if the leg is stationary, it can pull the pelvis. Yeah? Because let's just face it, muscles are kind of just meat. They're dumb. And they only do one and one thing only. Pull. When they get the command, they go, pull. And they pull on everything. Everything that they attach to, they pull. So if you think of Arnie Schwarzenegger in his early acting days, Conan the Barbarian, act. Okay. That's all he does. He just pulls, right? So, sorry, Arnie. I don't think he did much better in the political world either, but there you go. So, which tells you I actually saw the movie. Oh. All right, so then you have another muscle that arises at this little point here, just above your hip joint. It starts there, and it crosses the knee joint, and it attaches down here, like that. Now, that is one very long muscle. You can see the length of that. It's quite extraordinarily long. And that muscle is one of the quads at the front. And that also spans from pelvis to leg. Yeah. And then if you've ever noticed, sorry? No, they, the other quads, the strong ones that actually do that for your leg, they originate up here and then they cross the knee. This one actually crosses the knee joint, the hip joint and the knee joint. Then you have another one up here, the sartorius. And that kind of wraps around. Ooh, do I have? Could you pass me some Lutac, please? I've run out of Lutac. I thought I scored them all, but I didn't. Is it? Over here? Oh, that's, yeah. That's all right. Yeah, thank you very much. That's great. And it attaches over here onto this side, more or less roughly. Like that. And this is a really fun muscle because you can see it kind of makes a really shallow spiral around the leg. And they call it the tailor muscle because, you know, this is what tailors do. They sit their legs like that. Yeah? So that muscle will help that movement. Yeah. So can you already see that we've only got 1, 2, 3, 4 muscles attached, and already you have quite a number of very strong attachments going from pelvis to leg. Now, some of the strongest attachments, and I won't put them all on, but this is just to give you a general idea, go from the bottom of the pelvis here. Sorry, this inferior quality. Or maybe I'm just nervous. I think I'm more nervous than this is an inferior quality. So it goes here, and literally these muscles fill the whole inside surface of the thigh. Because if you think about it, look, this is it's a very long but strong bone, but it's not that thick. And yet, when you're standing, this is all full. The thigh bone's there. This is all full of muscle. So there's a hell of a lot of muscle that's there to draw in the leg. When you're sitting on the floor with your legs apart, they are on stretch, for some of you who haven't noticed. Yeah? And so they're ready, they really are ready to pull the pelvis. So these are the ones that majorly attach to the front and wrap around to the front portions of the legs. If you spin the guy around, you then have the good old hamstring muscles, yeah, that attach, guess what, your sitting bones at the back there, to one side of the knee, and the sitting bones, goop. And the sitting bones to the other side of the knee. And these are very powerful muscles. Yeah, without these muscles, climbing would be a little bit hard. Yeah. Oh God, yes. Yeah? Really? Wow. Thankfully, there's redundancy in the body. There's other muscles that could take over the work, but of course, you've drastically reduced your capacity to push. Yeah? Yeah, because when a muscle contracts, it pulls on the bone, and then the bone can either pull or push. Yeah? And then these good old guys, your butt muscles. Where are you hanging? I know you're there somewhere. There it is. Yeah. Huge, once again, huge muscles for climbing, for pushing backwards, for running. Yeah. For skiing. Maybe. For climbing back up the hill after you've had a good time, yes. Yeah. So already, can you see, just in terms of colours, the connectivity of pelvis to leg? Can you see that?
Soren, is that last one a glute minimus? Or
yeah,
okay.
glute maximus. So I won't put all the glutes. But basically, then if you attach the ilium to the sides here, you've got a whole other ray of muscles across here. So already you're getting this idea that in terms of the connection of pelvis to the lower limb, it's quite extensive. All right. Through the issue? Through that little, through here? No. Oh. Yeah, there could be the obturator. Obturator might go through here. Don't ask too many detailed questions. I only study anatomy for purpose. I am. I hate not knowing. Believe me, that's what makes me go to home at night and read up books. I hate not knowing. It's really. I don't. No, Iliopsoas goes over this like little waterfall cliff, so you can see how I think about anatomy. If I try to give it an image, I remember. Yeah. So yeah, something does go through this tunnel, but I can't remember the name of the muscle and I can't remember the name of the insertions. Yeah, you've got a lot of stuff going through those. You know, wherever you see little spaces like that, lots of things sneak through. So what I haven't done is attach all these small muscles that lie inside the pelvis to the top of the leg. So they're quite small, very precise, but if you do go and have a look at your anatomy programs, and I think the Visible Body Program, Muscle Premium, you can actually hide. You can hide every muscle that doesn't attach to the leg, and then you end up with this kind of same image. And then you can actually rotate it, go inside it, and you see it's very extensive. Yeah. So, could you chuck me to the yellow one? Yep, that's great. Thank you.
Can you put that red one back? That one that's fallen
Oh,
down.
where'd that come from? Oh, it's this one. Okay. Now, the way I used to teach students anatomy was not to look at the books first when it came to muscle. So I introduced the principle, muscles, when they contract, they pull. And to move bones, they have to cross a joint. So two principles. All right. Here's some streamers. There are the skeletons. Could you put a streamer that would bend the knee, please? And they would just take the streamer and put it where they think the streamer would be in order to bend the knee. And then I asked them, now, can you give the muscle a name? And some of them were much more creative than others. Some of them would call that muscle the butt kicker because that would come up and kick your butt when you bent your knee. So, so they would name it. And then they'd go look it up in the book. So rather than looking at the book, you would take two principles and you would put muscles where you think they would be to move the skeleton. It's a great game to play. And then you can go and check it up in the book. And later on, what I discovered was Feldenkrais kind of played the same game, but with neurology. He would try to guess where in the brain a particular function lied in order for such and such a skill to appear. And he'd try to figure it out based on his electrical engineering, and then he'd go up and look up the neurology book. So then he had a definite question. Well, where is it? What part of the brain is that? So the same thing here. Is there really a muscle there? What's it called? Is it anything like I named it? Nice game to play. Nice game.
We've got an additional tool is that we can actually put our hands on and feel ourselves. Is there something there that's moving?
Yeah, absolutely. Absolutely. So these muscles, the good old six-pack, which are really eight-pack muscles. I don't know why everybody calls them a six-pack. They're really an eight-pack. Yeah, the large, very large, long abdominal muscles. They're the ones that are most well known, but you see, I couldn't use chords for the rest of them because the rest of the abdominal muscles that join the pelvis to the rib cage, they just wrap. They wrap in sheets across here. They're the most surface ones. They're the ones right on the outer surface. And they're like two very thick cords running down the front. Yeah. So every time you rolled your pelvis to 6, these were definitely involved, as well as all the others. Yeah. So that's a major attachment from the pelvis to the rib cage at the front, in cords and in sheets. Because this is all open space. I think, remember for those of you who here at segment 1, Susan was talking about the volar surfaces. This is all volar surface. The only thing stopping anything getting towards your viscera, the nice juicy bits for carnivores, is your abdominal muscles. So this is where you're at your most vulnerable. So biologically speaking, this is the part of yourself that you protect. Yeah? Along the back, you have, I'm looking for them, they're gone. Is there? At the back, you have a set of muscles that span from the top of the ilia to the lower ribs. And you know, when I was saying, you know, can you feel how the rib cage changes shape as you take movement this way and how things get arched? These muscles are basically shaped like a rectangle, and so they get called quadratus because it's shaped like a quadrangle, quad. So, quadratus lumborum. Yeah. And then, just to finish it off, although this is probably the most inaccurate of all of them, you have a whole series of muscles that go from the pelvis all the way up along the back, but of course they operate in overlapping sections. And these ones are called, generally speaking, the erector spinae. In other words, they erect the spine.
One muscle.
No, every muscle is highly differentiated. Yeah, one muscle belly can consist up to, 10, 15,000 muscle fibers, depending on how big the muscle belly is. So every muscle is highly differentiated. We usually think about it as muscle bellies working, but actually it's muscle fibers in teams that work. Yeah. So as a rough visual image, I didn't attach all these ones on the other side, but if I kept on attaching streamers, you would see that almost every part of the lower limb and trunk is somehow connected to the pelvis. Yeah. And if you can visualize that, for those of you who are very good at visual imagery and can take that visual imagery and then put it inside yourself, that can help you no end. Because you can say to yourself, all right, so there's that line from here to here. I will now shorten that line. Ah, there it is. There's that line from here to here. I will shorten that line. Yeah? And it gives you lines of motion straight away. Boom, boom. So it's nice to think in abstract lines of motion. They can suggest directions of movement. Yeah? So remember the two principles? Muscles only shorten. Arnie Schwarzenegger. Yeah? And for a muscle to produce a movement, it has to cross a joint. Has to. Most muscles cross several joints. Yeah. Once you put those two things together, you can go over to the skeleton and you can just imagine where the muscles will be.
So they only shorten with force, but they unshorten.
Yes, they unshorten. Well, lengthening is a description of what happens at the two ends. They come closer together, they move apart. Then the question is, what takes them apart? Yeah, but now you're talking about neutral position of joints. Yes, it's called the preparatory phase. we're getting complicated. Too complicated. Too complicated. Too complicated. Too complicated. You see, one of the things that they haven't yet done is to create a program that will show you muscle activation in real time. The complexity of that is huge. If you look on YouTube, you'll see that there are some programs where you see this 3D model working, and it's based on the highest technology. And you can see these little red and blue. Blue means the muscle's turning off, red means it's coming on. And the rapidity with which things flash on and off is extraordinary. For you to try to figure that out in ATM, you will be distracted till the cows come home. So that's why, and maybe I'll finish off on this point, that's why Feldenkrais for most of the time thought about the motion of the skeleton in space. Because if you can have a clear notion of where the skeleton is going, then your brain will contract the appropriate muscles to do so, according to the image. And this is, this is a Feldenkrais concept, the image of the action. In other words, you have in your mind an idea about what you're about to do, what it's going to look like, the shape of it. It's in there. You formed it, whether you're not conscious of it or not, you have. And so the brain kicks in and makes that happen. You don't have to think about, will this muscle fire, will that muscle fire? In actual fact, that's very, very counterproductive. You're actually interfering with a physiological process that's taken many, many millions of years to evolve. Don't muck around with it. Yeah? So the clearest thing that you can do is have an image, have a clear idea. I'm going to take my hand there. You do it. I'm going to take my head towards 6. You do it. I'm going to take my head towards 12. Yeah. You do it. And you get shaped. That's why he was so interested in the skeletal blueprint. Once you have the blueprint, you can put whatever you like. Oh, you want white walls, blue walls? No. Then the architect comes in. Oh, we've got the blueprint. Now we can figure out all the other details. Make sense? Yeah.
If then, for some reason, your blueprint isn't firing as it should be, and you're in an ATM, and the idea is, to become more aware and create better movements, but for some reason, you're sartorius and everything else isn't firing properly, and you're not necessarily conscious of it not firing properly. So you kind of think you're doing the movement like you really should be, but you're just making something that's more habitual, that's possibly not working properly.
Yep.
In an ATM situation, how can you then, become aware of that without someone saying, oh, you're rocking, your pelvis is swaying, you should be going. Is that?
Yeah. So you're asking a question that has to do with the borderline between ATM and FI.
Yes, probably.
Yep. So let's say that you and I were doing a one-to-one session, but using ATM, and you asked me that question. Then my job as a teacher is not necessarily to immediately go to, okay, let's see if we can get that muscle firing. My job as a teacher is to know what kind of skeletal movement needs to take place for that muscle to kick in. How does the skeleton move through space for that particular muscle to actually have to work, because otherwise it ain't going to move. Yeah? So that's what you find in awareness through movement, these crazy variations which sometimes you say, why on earth are they torturing us? Like this one. Do you remember this one? Where you're off onto one side and you're leaning on this hand? Yeah. So you see, this is nice and lowered. Now you're going to have to kick in these back muscles, or else you're not going to go anywhere. So every different variation is trying to create a scenario where you're more likely, and I'm saying this deliberately, you're more likely, there's not 100% guarantee, you're more likely to find a particular coordination that you might not have been using a moment ago.
Great.
So rather than going directly for the muscles, you go, okay, what kind of movement do we need to make with the skeleton to see if we can kick that muscle in? Or the opposite way around. How do we need to configure the skeleton so that muscle can actually just rest a little bit? Both. Yeah. And that's the cleverness of the guy. God, his variations. Eventually, if you do all the pelvic lock lessons, believe me, you will encounter every different thing, because he doesn't do them in this set. But there's changes in leg position, one leg flopped, one leg upright, both legs flopped, both legs long, one leg tucked behind. Yeah. And eventually you find each of those things. Yes. Yeah, yeah.
If you were to pursue
yeah. Yeah. It's like a collie moving sheep into a corral, you know? This way, yeah? So that's what you learn when you become ATM teachers. In the first instance, you learn it from an internal perspective. What does all this feel like from an insider perspective? Because what we're doing here and how I'm talking now is the second part, the body as object. So you can have if you have a greater outsider knowledge, for those of you who have those skills already, who've studied anatomy, who have studied biomechanics, then you have a great outside perspective. And when you mix that with an internal perspective, that's a great combination. It's really important. Yeah. Any other questions before we do another lesson? I'm sorry for all these upfront kind of me talking head talks, but that will stop soon. Okay. Yeah. That's that. Piriformis. Yeah. Oh, yeah. That kind of goes. Yeah. All right. Cool. Yeah. Yeah. It's one of the 6 deep external rotators. Yeah, yeah. Yeah. No other questions? Another lesson? Okay.